Hello and welcome to helpyourmath.com. In this video, we're going to look at graphs of transformed sine and cosine functions. Before we get to those, let's review a few definitions. The first is amplitude. The amplitude of a sine or cosine graph represents the height from the middle line of the graph to the highest point on the graph, or we can say it's half the height from the lowest point to the highest point. We can determine the amplitude of the equation by taking the absolute value of a. So you can see here that a is the coefficient of either our sine function or cosine function. So we say amplitude is the absolute value of a. If a is negative, that just means typically that the graph, well, it depends on what we're talking about. If it's a sine graph, that means that the graph will go down first and then up. And if it's a cosine graph, that means it will start at the bottom and go to the top. But we can worry about that when we get there. The other definition to review is the period. So the period, if we look at the sine or cosine function, if something's being multiplied 2x within the function itself, that's going to affect the period. So the period represents the length of one complete cycle. And normally a period is 2 pi, but if there is a b value besides 1, we would figure out the new period by dividing 2 pi by b. This is also making the assumption that the domain is in radians. Okay, so in these examples, we're just going to determine the amplitude and period of the graph of each equation. So here, for the first one here, we have y equals 2 times sine of 4x. The amplitude, remember the amplitude is found by taking the absolute value of a. Well, in this case, a is 2, and the absolute value of 2 is 2. So the amplitude is 2. The period is found by dividing 2 pi by b. In this case, b is 4. So we would have 2 pi over 4, which would give us pi over 2. So in this graph, y equals 2 times sine of 4x, one complete period would happen in pi over 2 units. So much shortened cycle than the typical 2 pi. In our second example, we have y equals negative 3 times the cosine of 5x. The amplitude is going to be the absolute value of a, which is going to be the absolute value of negative 3, which is 3. And then the period, that's going to be found by taking 2 pi and dividing it by b. In this case, b is equal to 5, so one complete period here would be 2 pi over 5. I mentioned the negative before, so because this is a cosine graph, a normal cosine graph, one period would look like this. In the case of a negative, it's going to be the opposite of this. So this is a normal positive a. When we have a negative a, it's going to start at the bottom and go back to the top. So it almost looks like an omega, but it's just part of a curve. Okay, so talking about graphing these transformations, what is sine of 0? Sine of 0 is 0, right? So we usually on a sine graph, we would have the point 0, 0. However, a sine graph can follow the same transformations as other functions. So where we would normally have a point for sine at 0, 0, if we have the transformed a times sine of bx minus c plus d, we would have a new point here. So remember, a is going to tell us the amplitude, and b is going to help us determine the period. So we can say period equals 2 pi over b. So it's c and d that are going to be affecting where the starting point is for any sine graph. So the x-coordinate will move based on c, and the y-coordinate would move based on d. So instead of 0, 0, a sine graph would now have a point at c, comma, d. Okay, so for each of these, we're going to state the amplitude and period and one point on the graph. So the amplitude here, I'm going to label everything. So a is 2, b is a half, c is 0, and d is 3. Amplitude is found by taking the absolute value of a, so it's going to be 2. The period is found by taking 2 pi and dividing it by b, so it's going to be 2 pi divided by a half. This is the equivalent of 2 pi times 2, so the period here would be 4 pi. And one point on the graph, so this is a sine graph. A sine graph should normally be at 0, 0. The x-coordinate will not change, but the graph is being shifted up 3 units, so it will be at 0, 3. In the next example, we have y equals 2/3 times sine of 2x minus pi over 7 minus 1. So let's label. We have a is 2/3, b is 2, c is pi over 7, and d is negative 1. So amplitude is found by taking the absolute value of a. The absolute value of 2/3 is 2/3. The period is found by taking 2 pi and dividing it by b. This is 2 pi divided by 2, which is pi. And 1 point on this sine graph, so again, sine should start at 0, 0, but now it's being shifted to the right by pi over 7 units, and it's being shifted down 1 unit, so we would have 1 point located at pi over 7, comma negative 1. Okay, so now we're going to be given a graph. We want to determine the amplitude and period, and then one equation for the following graph. So judging by this, it starts at the top, goes down, and comes back to the top. So this indicates to me that it's a cosine graph, right? Because sine usually starts in the middle and goes back to the middle, whereas cosine starts at either the high or the low and goes back to the high or the low. All right, so we know that this is a cosine graph. Cosine graph. The amplitude, so we want to try to find the middle line. It looks like the middle line is going to be the x-axis here. And the amplitude will be from the top point to the middle line, and that's going to be 3. So our amplitude is 3. We also know based on this that a is positive, lowercase a is positive 3, because the graph starts at the top. If the graph started at the bottom, then we would know that a is negative 3. The period, so the period tells us, or we determine the period based on top to top when it completes one cycle. It goes from 0 to pi, so the period is pi. If we're going to write the equation, then we need to figure out the value of b. So remember, the period is determined by 2 pi divided by b. Well, in this case, we need to figure out b, so we're going to plug in for the period. We would have pi equals 2 pi divided by b. We can multiply both sides by b to get rid of the denominator, and divide both sides by pi to isolate b, and it looks like b equals 2. So now we can plug in. There's no transformations in terms of shifting left or up or down or right, so we could go ahead and write our equation. I'll call it g of x just because I can. So g of x equals 3, because of the amplitude being 3, times cosine of b times x. B is 2, so it would be 2x. So this is one possible equation for the graph shown on the left. In this example, let's see what we have. We start in the middle, we go to the top, we go back to the middle, we go to the bottom, we go back to the middle. So this indicates to me that we're dealing with a sine graph. And remember, we want to think about our transformations. So transformations are going to be found based on the amplitude, the period, and then if we're shifting left or right or up or down. We don't need to worry here about C or D. We're only looking at change in amplitude and period. All right, so to find the amplitude is going to be from the middle line, which is going to be here, to the top or the bottom. The top is here, so this is a distance of 2. The amplitude is 2. Since the sine graph is doing what it should, it goes up first and then down, we know that the lowercase a, what we're going to plug into the function, is also 2. Next, we want to figure out the period. So the period is going to be one complete cycle. We start here, we go up, we go down, we end back where we started. That took till 4 pi, so the period here is 4 pi. If we're going to write the equation, then we need to relate the period to the coefficient b, or the variable b. So remember, period is 2 pi divided by b. We know the period is 4 pi, so 4 pi equals 2 pi divided by b. Let's multiply both sides by b. We get b times 4 pi equals 2 pi. Then we would get b is equal to 1/2 if we divide both sides by 4 pi. So now I have my b, I have my lowercase a. We can write the equation of this sine function. It would be g of x equals 2 times sine of 1/2 x. There's no shifts, so we don't need a c or a d. 2 more examples. Here we want to do the same thing. So it looks like here we're starting at the top. We go down, down. Here's the middle. Here's the bottom, middle, top. So we can see that one complete cycle. Because we start at the top, this should indicate to us that it is a cosine graph. So we know we're dealing with cosine here. So again, what we want to do, and there's no vertical or horizontal transformation, so I'm only going to focus on a and b here since we don't need the c or the d. It's going to be a times cosine of bx. And now we want to determine lowercase a and lowercase b. We can determine lowercase a by starting with our amplitude uppercase a. And if we look here, so the middle line is again the x-axis since there's no vertical shifts. And it looks like it goes exactly halfway between 0 and 2, which would be 1. So our amplitude is 1, and our lowercase letter a is also 1. The period here, so it's going to start at the top, and when does it get back to the top? Okay, this one looks a little ambiguous, so we need to try to figure out something else, because I don't know. I know this here is 3 pi over 4, so it's somewhere in between pi over 2 and 3 pi over 4, but this isn't very clear to me. So what we might do is we might try to find another cycle. So maybe I go here. That's not really helpful either, because that's not going to tell me a great x coordinate. But if I go here, okay, this helps. So now I know that 1, 2, 3 cycles, right? This is 1 cycle, 2 cycles, 3 cycles, give me 2 pi. So 1 cycle, or 1 period, will be 2 pi divided by 3, because 3 cycles was 2 pi. I only want 1 of those, so I'm going to divide it by 3. Now I know the period is 2 pi over 3. That's great, but that doesn't help me write the equation. Well, it does, but we're not quite there yet, because we're going to need to take that value to figure out what the b value is in the equation. So we're going to say the period, 2 pi over 3, is equal to 2 pi over b, and hopefully you can look at this and just tell what b is. B is 3. Okay, now we have enough information to be able to write the equation of this graph. This is going to be g of x equals, we don't need to put a 1, but you can if you want to, cosine of 3x. And that would be the equation for g. And our last example here, let's see. So we want to determine amplitude, and then lowercase a based on that, the period, and lowercase b based on that. Let's see, we start in the middle, we go to the top, middle, bottom, so we're dealing with a sine graph here. For sine graphs, we're going to say g of x is equal to a times sine of bx. Again, since there's no vertical or horizontal shifts, I'm going to ignore the c and the d for now. All right, so we're starting, it looks like the middle line is the x-axis again. And, well, it's a little bit hard to tell. It appears as though it goes about 1/4 the way up to 2, right? So halfway would be about here. This looks like it's half of halfway. So I'm going to say that the amplitude is a half. Since the graph goes up and then down, that means that lowercase a is positive, so it's going to be positive 1/2. When does it go back? So it goes up, it goes down, and then it goes back to the middle at pi over 2. So it goes from 0 to pi over 2. The period is pi over 2. We're going to use that to figure out the value of b. So pi over 2 is our period, and it's going to equal 2 pi over b. We can cross multiply here. That's b times pi equals 4 pi. Divide both sides by pi, and we end up with b equals 4. Now we have the necessary components to be able to build the equation. This would be g of x is equal to 1/2 times sine of 4x. Hopefully this provided a little bit of insight about transformations of sine and cosine graphs.